It's good to be back. Welcome back to my channel. My name is Setson. Today we're going to do a continuation of our introduction to OOP using Python. We are moving on to the second part. We're looking at Dunder methods. Initially, I had planned to have lesson 3 looking at the self parameter, but after I did some revision, I realized that I cannot possibly separate the self parameter and the Dunder methods. And so I'm going to introduce this self parameter in this particular lesson. This is what we're going to be covering. So we're going to look at what are Dunder methods, look at the categories of Dunder methods, the constructor method, the object representation, and other magic methods, which are Dunder methods. We're going to look at a little bit of theory, and then we're going to implement this in actual code. So in Python OOP, Dunder methods, this is short for double underscore. The special methods that have 2 underscores at the beginning and 2 at the end of their names. The double underscore init, double underscore str, double underscore, or double underscore a, double underscore. There are so many of them, but you might encounter a few that you might want to use. They are also officially called magic methods because they are invoked automatically by Python behind the scenes, not by you calling them directly. So you don't call these methods directly. You have to call another method which then invokes this double underscore. Okay, this is very important. They allow your custom objects to behave exactly like Python's built-in types. Almost everything in Python is an object, and those built-in data types are objects, and they have a certain behavior. And so if you want your custom objects to behave like those built-in types, you have to use these double underscore or the magic methods. So these Dunder methods can be grouped based on what they do. Here is the grouping. The Dunder method that do object creation and destruction. These are Dunder methods that control how objects are created and destroyed. I have listed a few here, but there could be more. The most common ones under object creation and destruction, there is the init. We're going to look at this. This is what we call the constructor. So this is the constructor or initializer. It runs automatically when you create an instance of a class. And then we also have the del, which is short for delete, the destructor. It runs right before Python destroys the object. We have Dunder methods for string and representation. It's making objects readable. These are Dunder methods that control how objects looks when printed or viewed. I have 2 here listed. Double underscore str, double underscore is called when we call print object. It should return a user-friendly readable string. We also have the wrapper. This one is called when we use wrapper object or when you type the object's name in the Python interactive console. If underscore string is missing, Python uses wrapper as fallback. We have double underscores for arithmetic and operator overloading. This is when you want to make your objects math friendly. Okay, so we have the double underscore add, double underscore sub, double underscore more, double underscore true division. They define the behavior for the plus, minus, multiplication, and division of your objects if you want to perform some arithmetic operations, but we're not going to be using this in this tutorial. And then we have the last category that I put, which is for comparison, which is for making objects sortable. These let your objects be compared using the greater than, less than, or equal. So basically, this is what we have in terms of categories of Dunder methods. Okay, so now we're going to jump into our code and then look at the constructor. So initially we had done this. We had called these properties, but I realized that in Python classes, properties is a reserved word for something else. So I'm not going to be using properties here. I'm going to be using attributes. Let's use attributes right here, which are features as well. We created this last time. So we said we could just say dog.legs. Obviously, this will print 4 because these instances have access to these attributes right here. In this case, we call these class attributes. They're accessible to every object, right? And they are also accessible to the class itself. I could say animal.legs down here using the class name. And if I'm to run this, you'll see 4 down here. But for these particular attributes, they are not really class level attributes. There are some that are class level attributes, but these are instance level attributes because their values could be different for each animal. For instance, if I was creating a bird right here, and I'll say animal, obviously a bird does not have 4 legs, right? It has 2 legs. And so how do you deal with that? So you have to create what we call instance attribute attached to a given instance. Let's go ahead and create these instance attributes. So for us to be able to create instance attributes, we have to use a Dunder method. But before I use the Dunder method, let me remove this bird so that we keep it minimal. So we could come down here like we did last time. We could say dog.let's say name. This dog has a name, bingo. And we also have the color of the dog. We say dog.color black. We want to do the same for the cat. Cat.name kitty, cat.color white. We have created the attributes here specific to each instance, but this is not the way that we want to do it. And so this is where we can then use a Dunder method called the constructor. It's double underscore init double underscore. So I'm going to define it here inside the class. So you use the def keyword and then you say double underscore init double underscore, and then you put these parentheses right here. So this is the right time for me to introduce that self parameter, which is something that we have to pass in these methods. So these methods are called instance methods. In Python classes, you're going to deal with three different types of methods: instance methods, a class method, static method. These two, you use decorators when you're creating or defining these. For a class method, you use a class method decorator. And then for a static method, you're going to use a static method. But for instance methods, you don't have to put any decorator. I just wanted you to know that these are the methods that you can use. All right, so I'm going to remove this pass right here because we now have stuff in our class. And so this is what we call the constructor. Is called automatically when we create an instance of a class right here. So this is the right place where we can then initialize these attributes inside this init, because it's automatically called each time we create an instance like this. So let's do that. However, Python needs to know which object it's dealing with, because here we knew which object we're dealing with because we created the object first and then we created the attributes. But then Python, when you do this, does not know which object you are dealing with. This is where you need to talk about this self parameter. This is the first thing you have to pass into an instance method, which represents the object that you are dealing with at that given moment in time. So if you are dealing with the dog, then Python will know that this will be a dog. If you are dealing with the cat, then Python obviously will know this is a cat right here. Let's try and print this self. So we no longer need this plus. We're supposed to have two selves. Clear down here and run. These are the two objects that are being passed. But of course, you cannot see whether this is the cat or this is the dog because of the representation. We're going to look at that later on. So each time we create an instance, this is code. And so Python prints this. And then when we created the second one, it printed again this one. And so after this self, we can then pass in name, because this is the attribute right here, dog.name. And then we can also do the color. Now we can just use this self.name. And of course, the value is going to be this name that we're going to pass here. So the value is going to be name. So when we create our dog, we can pass in the bingo right here. So I'm going to cut this bingo and pass it right here, because we have passed it up here. It becomes the value, this name right here. But this name on this side is the attribute. It's this attribute that we have. Same with the color. What is the value of the color? It's black. So let me cut this, put it just after this, paste it right here. Of course, you have to separate with commas. And of course, you have to create that attribute here. We can say self.color is color. Of course, we no longer need these two. The name and the color are placeholders. They will be replaced by the actual values that you pass. And so you pass them into this animal class. When you initialize this animal class, the left side is the attribute and the right side is the value. So this name can be maybe f_name. But this name should be similar to what you write here, because it's the value. So now your objects, we have an f_name attribute, not a name attribute. So this kitty is going to be here. So let me just write white here, and then we do away with this. We no longer need this. I can print dog.f_name. You can do the color as well. Let me dog.color, because it's the attribute. Okay. Now if I run this, you can see it says bingo and black. The dog has a color of black, which we passed here, and it has an f name of bingo. However, the convention is to match these two, this parameter and the attribute. You can just call it name. So down here now it's no longer f name, it's now name, like that. All right, so the constructor is a place where you want to initialize anything that you want to run when you create an instance of a class. Okay, so let's say you wanted to print something here. You wanted to say an object has been created. So each time you create an object, you get this printed in the console. So let me save Let me clear, let me run, and you can see it says an object has been created and another object has been created. So I'm going to do away with this. We don't need this. Sometimes you want to keep a count of the objects that you have created. In this case, we have animals, so we could say total animals. This is a good candidate for a class attribute. So this becomes a class attribute. It's at class level. So then how do we keep the count? So we can do it inside here. Each time we create an instance, init is code. And so we can then say animal.total animals plus equal 1. We increment the total number of animals each time we create an instance of this class. This is what we're doing. Why did I use animal for this particular attribute? Because it's a class level attribute. So you cannot say self.total animals. We can check the total number of animals by printing right here. Animal.total animals, we're supposed to get it 2 because there are 2. If I run this, you see down here 2. But with this done, I wanted to explain something to do with the object itself. Each time we print the object, this is the object representation at this given moment in time. We just know it's an animal object at a given location in our memory, but we don't know the exact object. This is when you have to use that _str or _wrapper. So you can define another instance method, but it's a Dunder method, str _. And of course it takes in the what? The object, which is the self, and nothing else. And here you have to return a string. So I can return an f string. I want to return the name and the color. So I can say here self.name and also self.color. Okay, so why are we passing self? Again here, because Python needs to know which objects it's dealing with. If it's a dog, then this will be a dog. So here dog.name will be bingo, dog.color will be black. And if it's a cat, it does the same. So when do we code this? We don't directly code this, just like we do not directly code this __ in it. This str is code when we print. Let's see whether this is going to work or not. So if I clear this and run down here, now you can see we're getting bingo black because this is what we defined here using the __ str. By the way, I want to talk about this self. It doesn't necessarily have to be called self. You can name it any other name, but this is the convention by Python programmers. It's similar to this keyword in JavaScript. So I could say this here. It doesn't necessarily have to be self. So I can say this here. So now this becomes this.name and also this.color. If I clear this and run this, you can see it's still working because it's not a strict rule. It's just a convention. However, you want to be using self because this is the Pythonic way of doing things. All right. So the next part is to talk about the _wrapper, and then we finish. So we can define a _wrapper, Again, it takes in the self, which is the object. And then you can return something here. I want to return an f string which says my name is the self.name. So we say this can be a fallback for this one right here, and also use it in different circumstances. Let's say we didn't have this, so the print now will return this value right here. Let me remove this line right here because our stuff is being cluttered. Okay, so let me clear this and let me run this. You can see now when we print the object, you say my name is bingo, and if we do the same for the cat, we can print the cat right here. So let me run that down here. You can see my name is Kitty and my name is Bingo. This is the summary for lesson 2. We talked about Dunder methods and we said it's short for _. These are special methods. They're also called magic methods. And also these Dunder methods can be grouped based on what they do. Yeah, so we have come to the end. If you have any questions, you can leave them in the comment section. If you like this type of content, you can leave a like. You can also consider hitting that subscribe button. I hope to see you in my next tutorial. For now, I'm out. Cheers.